Okay, let's move on to our next topic. We will be discussing the inverse trigonometric functions of the complex number z. So take note of the convention. If you can see this convention, this is sine with an exponent of -1. That is actually the arc sine function. Same as well as for cosine raised to -1, that is arc cosine function. You can find that in your calculator. So for tangent, that is arc tangent. So don't confuse that as the reciprocal of the function. Okay, that is just the arc sine, arc cosine, and arc tangent function. But in our topic, we will not be using that convention. So, okay, so problem number 1, I have here, what is the value of the arc sine of the complex number z? Okay, that's a big question. So take note that z is equal to x plus jy. So that is a complex number, x plus jy. So our solution will start by letting arc sine of z equal to the variable a. So in this case, a is equals to arc sine of z. Take note, z is equal to x plus jy. Now, if we are going to transpose arc sine towards a, it becomes, okay, we will transpose arc sine towards a. That is actually taking the sine function of the equation. So sine of a equals to sine of the arc sine of z. That is taking the sine function of the equation. So in short, you can just transpose that to the other side to become sine of a. Now, z will remain on the other side of the equation. So if you can still recall, the value of sine is e raised to j theta, but in that case, your theta is equals to a, so that is e raised to j a minus e raised to minus j a all over j2. That is equivalent to your complex number z. Now, if we are going to simplify it further by multiplying j2 to the other side of the equation, or you can just do cross multiplication. So what will happen here is e raised to ja minus ja will be equal to j2 times the variable times the complex number z. Now, if we are going to multiply the whole equation by e raised to ja, we can have a quadratic equation. That is, if we multiply e ja by itself, that will become e raised to ja squared. And if we will multiply e raised to minus ja by e raised to ja, that will become e raised to 0. That is under the principles of algebra. So e raised to 0 is equal to 1. Now that is if it equal to j2z multiplied by e raised to j times a. Okay, now if we are going to equate that to 0, take note, we have now produced a quadratic equation. So quadratic equation of e raised to ja. Take note, this is now your quadratic equation. If you can still recall, now in your algebra, quadratic equation is ax squared plus bx plus c equals to 0. And do you know how to solve for x? Okay. That is using the quadratic formula. So in this case, x is equals to minus b plus minus square root of b squared minus 4ac all over a. But in the case of the equation above, since we are not using x, we are using e raised to ja, Therefore, e raised to ja can be solved using the quadratic formula. Now, the coefficient of that equation, no, is, take note, for b, that is negative j2z. That is negative j2z plus or minus square root of b squared. Now, if you are going to square minus j2z, no, the result will become a square negative, that's positive, square j, that's negative, square 2, that's 4, square z, that's z squared. A minus 4 times a, take note of the coefficient, that is 1, times c, that is negative 1. Okay, all over 2 times the coefficient a. So that is now your value of e raised to ja. Now we are going to simplify, okay, the numerator first by multiplying negative 2. That value becomes positive 2jz plus and minus. Take note, if we will multiply, if we will simplify the terms inside the square root sign, that will become, and we will factor out 4, no? That will become 4 minus 4z squared. Take note, you have a common term there, which is 4. And if we are going to factor out 4, what will happen to the terms inside the square root sign? So this will become 4 times 1 minus z squared. Take note that is 4. So 4 is actually a perfect square. So we can take the square root of 4. That is equivalent to 2. So putting 2 outside your root sign. So what will be left? Oh, by the way, 4 should not be there. So you have to erase 4 there. 4 should not be inside the square root sign because now we have taken the square root, which is 2 square root of. That should be 1 minus z squared. I'm sorry now for the value 4, but it should not be there. So therefore, if you are going to take the logarithm of both sides of the equation, on the left, the result will be JA times ln of E. Since ln E is equals to 1, it will just be JA. And of course, that is the logarithm for the other side of the equation. Now, if we are going to divide the whole equation by J, take note, 1 over J is equal to negative J. Try that in your calculator or in a piece of paper. 1 over J is just negative J. So therefore, you have negative j multiplied by ln of z plus or minus square root of 1 minus z squared. Therefore, the arc sine of the complex number z is just equal to negative j ln of jz plus and minus square root of 1 minus z squared. All right. Do you have any question? Okay, we will proceed to our next example, which is example number 2. So this time, now we will solve the value of the arc cosine of the complex number z. So what is arc cosine of z? Question mark. So we will start our solution by letting the variable a equal to the arc cosine of z. Take note, now if we are going to transpose arc cosine to the other side of the equation, it becomes cosine. Okay? And the variable remains on the right is z. So that will become cosine a equals to z. And take note, cosine a is equal to e raised to ja plus e raised to minus ja all over 2. Of course, which is equals to the variable z. Now, if we will linearize the equation by multiplying 2 to the other side of the equation, that will result to e raised to ja plus e raised to minus ja equals to 2z. And if we will multiply the whole equation by e raised to ja, now we can produce a quadratic equation. That is e raised to ja squared plus, take note, that will become 1 equals to 2z times e raised to ja. Now, if we will rearrange the equation, this will become minus 2z e raised to ja plus 1 equals to 0. Now we have a quadratic equation of e raised to ja. So we are going to solve for e raised to ja by using the quadratic formula. Take note that is the value that those are your coefficient. So this is negative b. So negative of negative 2z becomes positive, plus or minus square root of. If you square negative 2z, that will become 4z squared multiplied minus 4 times a times c all over 2 times the coefficient a. Okay, now simplifying the terms under the root sign, we can factor out 4. Okay, take note 4 there is a perfect square. So we can take 4 outside the root sign by taking its square root. That will become 2 square root of z squared minus 1 all over 2. Now, if we will divide the numerator by 2, so what will be left? So therefore, e raised to ja will now be equal to z plus and minus square root of z squared minus 1. Okay, now if we will take the logarithm of the whole equation, that will become ja equals to ln of z plus or minus squared of z squared minus 1. And if we are going to transpose y to the other side, that will become minus j. We will transpose j to the other side. That will become minus j times ln of z plus and minus square root of z squared minus 1. Therefore, our cosine of the complex number z is equal to minus j times ln of plus minus square root of z squared minus 1. Okay. Take note of this formula because you will be using this for future exercises. Now we will proceed with another problem. This time we are going to find the value of the arctangent of the complex number z. So we will start our solution. We will start our solution by letting a equal to your arctangent of z. Now, if we are going to transpose arctangent to the other side of the equation, that becomes tangent a, which is equal to the z, or the complex number, on the right side. And take note, arctangent of a is just a sine of a all over cosine of a. And sine of a is e raised to ja minus e raised to minus ja all over j2. That is your sine. All over cosine, that is e raised to ja plus e raised to minus ja all over 2. That is your cosine of a. Now, if we will simplify, 2 will cancel out. And j there now will be transposed to the other side of the equation. That will become jz, which is equals to e raised to ja minus e raised to minus ja all over e raised to ja plus e raised to minus ja. Now, if we are going to cross multiply, that will become e raised to ja minus e raised to minus ja is equal to jz multiplied by e raised to ja plus jz multiplied by e raised to minus ja. And again, we will multiply the whole equation by e raised to ja to make it a quadratic equation. So this time, this will be e raised to ja quantity squared. Okay, that will become 1. Okay, that will become squared, e raised to ja squared. And again, this will become 1. So what will remain here is jz. Now, if we will rearrange the equation so that similar terms will be together, by transposing jz e raised to ja quantity squared to the other side of the equation, and 1 to the other side of the equation, that is 1 plus jz. And then we will factor out. Take note, this is e raised to ja squared. Now, we will factor out the common term here. So that is e raised to ja quantity squared. Okay. So that what will remain after factoring out? Yes, 1. 1 minus jz, which is equal to 1 plus jz. Now, if we are going to divide the whole equation by 1 minus jz, so this is e raised to j quantity squared, divide that by 1 minus jz. Okay. After dividing, we are going to take the square root of both sides of the equation, leaving you square root of 1 plus jz all over 1 minus jz. This will become e raised to ja. Take note, square root can be transformed into power. Okay. And then if we will take the logarithm of both sides of the equation, take note, I will transform the root sign to the power sign so that we can perform the loss of logarithm. So for power, if you're taking the logarithm of a function raised to a power, that is power multiplied by the logarithm of the function. Okay, okay. Ja, now if we are going to transpose j to the other side of the equation, that becomes negative j. So therefore, the arctangent of the complex number z is simply equal to minus j over 2 times ln of 1 plus jz all over 1 minus jz. Okay. Now we go to some exercises or example problem. We will start our example by evaluating the value of arcsine J3. So for our first example, we are going to solve or evaluate the arcsine of J3. Okay. Now this time we are going to use the long method. Okay, we will be using a long method here. So in the long method, you are going to let arcsine J3 equal to the variable A. After that, we are going to transpose arcsine to the other side of the equation to become sine A, and the remaining complex number there is J3, or rather imaginary number. Take note that is the value for sine A. Now, if we will cross multiply by multiplying J2 times J3, that will become negative 6. So copy the numerator and then multiply the whole of the equation by JA to become a quadratic equation. Okay, that value will multiply to that value becomes 1. That is now minus 6 e raised to JA. Okay, rearranging the equation or equating the equation to 0, the equation will become your standard quadratic equation. Now, for the quadratic equation of e raised to ja, that is negative b, or negative 6, no, plus and minus b squared, that is 36 minus 4 times a, which is 1, times c, which is negative 1, all over 2a. So am I talking too fast? Can you still follow? Okay, just follow, no, what I'm writing here. So we will simplify the terms inside the square root sign. That will become 40. Okay, that is 36, no, plus 4 equals 40, or that is just 4 times 10. Take note, 4 there is a perfect number. I mean, perfect square. So if we are going to take out 4 outside the square root sign, that will become 2. And then square root of 10 will remain inside. So by dividing the numerator by 2, this will become minus 3 plus and minus square root of 10. Okay, that is now the value of e raised to ja. And then we are going, the goal here is to solve for a. So we are going to take the logarithm of the whole equation. So that will become ja, and then ln of negative 3 plus and minus square root of 10. Okay, now if we are going to divide the whole equation by j, that is just equal to minus j multiplied by ln plus and minus square root of 10. That is now the value of your arcsine of j3. So arcsine of j3 is equals to negative j ln of negative 3 plus and minus square root of 10. Okay. Now, we will solve the equation. We will solve the same problem using the short method. What do I mean using the short method? Short method is actually using the formula. So you need to recall all the formulas, no, that I'm writing here. So if you can still recall that the arcsine, okay, we have the arcsine of z is simply minus j that is minus j ln of jz plus and minus square root of 1 minus z squared. Okay, that's the value of the arcsine z. Now, if z is equals to j3, so we can have arcsine of z, arcsine of j3 equals minus j ln of j times j3 becomes j times j3. We will copy that. Plus and minus square root of 1 minus the square of j3. So the square of j3 becomes negative 9. Simplifying it further, this will become negative 3. Okay? Plus and minus square root of, that will become 10. Now, if we are going to compare our solution to our previous solution, okay, that is our previous solution, that is using long method, and this one is our answer using the short method. They are actually the same because the process, no, is also the same. Now, get a piece of paper and your calculator and try to solve this problem. Okay, try to evaluate the arc cosine of J3. I will give you 20 minutes to solve this problem. So don't forget to pause this video for a while and solve the problem for 20 minutes only. Okay, are you done? Okay, time is up. 20 minutes is over. Okay, I will reveal the answer here. So the answer to this problem is minus j ln of 2 minus j3 plus and minus square root of minus 6 minus j12. Did you get it right? Okay.